Hello, fellow Voyagers, and welcome to the Night Voyager. I'm absolutely delighted you've chosen to join me for what might be one of the most profound journeys we'll take together. The Fermi paradox keeps scientists up at night, but tonight it might just help you fall asleep. Wherever you are, I hope you're feeling safe, still, and ready to let your thoughts drift into the stars. If these gentle explorations of the cosmos bring you comfort in your evenings, I'd be honored if you'd consider subscribing to join our growing community of night sky dreamers. Tonight, we're embarking on perhaps the most existentially stirring question humanity has ever asked. It's a puzzle that sits at the intersection of mathematics and philosophy, hope and loneliness, wonder and cosmic dread. We're going to explore the Fermi paradox, that haunting question that echoes through the silence of space. Where is everyone? Our galaxy alone contains over 400 billion stars. Many of these suns are orbited by planets, and countless worlds likely sit in that perfect zone where liquid water can exist. The universe has had nearly 14 billion years to evolve life, intelligence, and civilizations. By every reasonable calculation, the Milky Way should be bustling with activity. Radio signals, megastructures, signs of intelligence that would be impossible to miss. And yet, when we point our most sensitive instruments toward the cosmos and listen with careful attention, we hear silence. A deafening, mysterious, almost mournful quiet that stretches across the star-filled dark. This paradox, first articulated by physicist Enrico Fermi during a casual lunch conversation in 1950, has grown from a simple question into one of science's most profound mysteries. Tonight, we'll drift together through the mathematical elegance that suggests aliens should be everywhere, and contemplate what our cosmic solitude or hidden company might mean for humanity's future among the stars. As we begin this gentle journey into the unknown, imagine that right now, somewhere in the vast cosmic ocean, there might be another conscious being looking up at their own night sky, wondering the exact same thing we are. Are we alone? The answer, whatever it may be, will change everything we think we know about our place in the universe. Let's begin with something that seems almost impossibly simple, yet carries profound implications that ripple through our understanding of existence itself. It's a mathematical exercise that starts with gentle curiosity and ends with a conclusion so startling that it keeps cosmologists staring at their ceilings long into the night. Close your eyes for a moment and imagine our galaxy as a vast ancient metropolis. It stretches in every direction, not just a city, but the ultimate cosmic neighborhood with roughly 400 billion individual houses, each one a star system with the potential to harbor worlds. Some of these stellar homes are young and energetic, others are ancient and wise, having burned steadily for billions of years before our Earth even began to form. Now, here's where mathematics becomes overwhelming. If even a tiny fraction of these star systems, let's say just 1%, developed habitable planets, we're talking about 4 billion worlds where life might take hold. But let's be even more conservative. What if only 0.1% of all star systems harbor planets suitable for life? That still gives us 400 million potential cradles of existence, scattered like cosmic seeds throughout our galactic neighborhood. The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to quantify this cosmic lottery with elegant mathematical precision. It's not a prediction so much as a framework for our cosmic wandering. The equation considers factors like the rate of star formation, the fraction of stars with planets, the number of habitable worlds per star system, and the likelihood that life, once it emerges, might evolve into something we could recognize as intelligent. Even when we apply remarkably pessimistic estimates to each variable, assuming that intelligent life is extraordinarily rare and difficult to develop, the numbers still whisper that thousands of detectable civilizations should exist within our galaxy alone. If intelligence emerges on just one planet for every million star systems, our Milky Way should still host several 100,000 thinking civilizations. That's like saying that in our cosmic city of 400 billion houses, hundreds of thousands should be occupied by neighbors sophisticated enough to send signals, build megastructures, or at least accidentally leak their television broadcasts into space. But mathematics becomes even more staggering when we consider the dimension of time. Our universe has been expanding and evolving for nearly 14 billion years. Earth formed about 4.5 billion years ago, and complex life didn't really flourish until the last billion years or so. This means the cosmos had a nearly 10 billion year head start on us. An almost incomprehensible expanse of time during which other civilizations could have emerged, evolved and spread across the galaxy. Think of it like this. If the entire history of the universe were compressed into a single year, Earth wouldn't form until late August, and human civilization would flicker into existence in the last few seconds before midnight on December 31st. That leaves more than 8 months, during which other worlds could have been developing life, intelligence, and technology. Some alien civilizations could be millions or even billions of years ahead of us in their technological development. The concept of a technological head start is perhaps the most vertigo-inducing aspect of the entire paradox. Consider how dramatically human technology has advanced in just the past century. We've gone from the first powered flight to landing on the moon in less than 70 years. We've developed global communication networks, artificial intelligence, and are beginning to manipulate matter at the atomic level. Now imagine what a civilization with a million-year head start might achieve. They could have technologies that appear to us as pure magic. The ability to harness the energy of entire stars, to travel between worlds as easily as we cross oceans, to communicate across galactic distances instantaneously. Such ancient civilizations might construct what scientists call megastructures, engineering projects on scales that dwarf anything in human imagination. They might build massive arrays of solar collectors around their stars, creating what's known as a Dyson sphere to capture every photon of stellar energy. They might terraform entire worlds, turning barren planets into gardens. They might even disassemble planets to build computational matrices the size of solar systems. These projects would be visible from enormous distances, detectable by any civilization with modest astronomical capabilities. Even if these advanced beings had no interest in communicating with younger species like ourselves, their mere existence should leave unmistakable signatures across the electromagnetic spectrum. Their power consumption alone would create infrared heat signatures visible to our telescopes. Their industrial activities would produce atmospheric changes detectable in the spectra of their worlds. Their spacecraft, if they built any, would occasionally block starlight as they transit between worlds. Yet when we scan the skies with our most sensitive instruments, carefully analyzing the light from thousands of nearby star systems, we find nothing. No obvious megastructures, no clearly artificial radio signals, no atmospheric signatures of massive industrial civilizations. The galaxy appears strangely pristine, as if intelligence were a recent and local phenomenon. This brings us to one of the most unsettling aspects of the mathematical paradox. Even if advanced civilizations were extremely rare, say, only one emerges every billion years in our galaxy, we should still expect to see evidence of dozens of them. These would be civilizations with millions of centuries to develop technologies we can barely imagine, to spread across multiple star systems, to leave marks on the galaxy that would be visible from thousands of light years away. The silence becomes even more puzzling when we consider that some theoretical calculations suggest that a sufficiently motivated civilization could colonize the entire galaxy in just a few million years. This sounds impossibly fast, but remember that our galaxy is only about 100,000 light-years across. Even traveling at a modest 10% of light speed, which seems within the realm of possibility for advanced technology, it would take just 1 million years to cross from one side to the other. And colonization doesn't require faster-than-light travel. It could proceed like a slow wave, with each new settlement serving as a launching point for the next. Imagine this expansion like a gentle tide washing across a cosmic shore. A civilization develops interstellar travel and sends colonies to nearby star systems. Each colony, once established, eventually develops the capability to send out its own expeditions. The process repeats, creating an expanding sphere of settlement that grows steadily outward. Even if each step takes thousands of years, and even if only a small fraction of colonies succeed, the mathematics suggests that the entire galaxy could be explored and settled in a time span that's brief compared to the age of the universe. This is sometimes called the galactic expansion argument, and it leads to a particularly stark conclusion. If technological civilizations tend to expand across multiple star systems, then the first species to achieve interstellar travel should have had enough time to colonize the entire galaxy several times over. The fact that we see no evidence of such colonization suggests either that we're among the very first to reach this level of development, or that something prevents civilizations from expanding in this way. The numbers, no matter how we arrange them, keep pointing toward the same bewildering conclusion. Whether we're conservative or optimistic in our estimates, whether we consider biological life or artificial intelligence, whether we assume rapid expansion or cautious exploration, the mathematics consistently suggests that our galaxy should be rich with detectable signs of intelligence. And yet, here we sit, apparently alone in our small corner of a vast cosmic city, surrounded by 400 billion stellar homes that appear empty, quiet, and strangely devoid of the neighbors that mathematics insists should be there. It's as if we've moved into an enormous apartment building and discovered that every other unit is dark, every other mailbox empty, every other window blank. This is the heart of the Fermi paradox. Not just that we haven't found aliens, but that every reasonable calculation suggests we should have found them already, probably multiple times over, in ways so obvious that missing them would be nearly impossible. The cosmos should be singing with intelligence, and instead it whispers only silence. Let that cosmic mathematics settle in your mind for a moment, because what comes next makes the paradox even more profound. For over 6 decades, we haven't been sitting passively wondering about our cosmic neighbors. We've been actively searching, listening, and calling out into the void with increasingly sophisticated technology. And the response has been, well, that's precisely the mystery. The search for extraterrestrial intelligence began not with grand government programs or massive installations, but with a simple, almost romantic idea. In 1960, a young astronomer named Frank Drake pointed a radio telescope toward 2 nearby sun-like stars and listened carefully for any signals that might be artificial rather than natural. He called it Project Ozma, after the fictional princess who ruled a distant land in the Oz books. For 200 hours, Drake listened to the cosmic static, hoping to catch a whisper of intelligence from across the light years. Imagine that first search. A lone scientist in the early morning hours, headphones on, scanning slowly across frequencies while the rest of the world slept. The telescope was modest by today's standards, and the computing power was virtually non-existent, but the hope was enormous. Drake was doing something no human being had ever done before, conducting a scientific search for signs of cosmic intelligence. The idea behind radio astronomy as a search method is beautifully logical. Radio waves travel at the speed of light and can cross enormous distances without being absorbed or scattered by interstellar dust and gas. An advanced civilization would likely discover radio technology, just as we did, and might use it for communication between their own worlds or facilities. Even if they weren't trying to contact other species, their signals might leak into space. Their equivalent of television broadcasts, military radar, or navigation beacons. From our perspective here on Earth, such signals would appear as artificially structured patterns amid the natural radio noise of the cosmos. Stars, galaxies, and nebulae all emit radio waves, but these natural signals have characteristic signatures. They're typically broad spectrum, randomly fluctuating, or tied to specific astrophysical processes. An artificial signal, by contrast, might be narrowly focused on specific frequencies, might carry encoded information, or might repeat in patterns that no natural process could create. As the decades passed, our search capabilities grew dramatically more sophisticated. The sensitivity of our radio telescopes improved by factors of millions. We learn to filter out human-made interference, to automatically scan across millions of frequencies simultaneously, and to apply pattern recognition algorithms that could spot artificial signals hidden in cosmic noise. Projects like SETI even enlisted millions of personal computers around the world, turning the search for extraterrestrial intelligence into one of the largest collaborative scientific efforts in human history. Today's search efforts are breathtakingly comprehensive. The Breakthrough Listen project, launched in 2015, represents the most ambitious search ever undertaken. It monitors over 1 million nearby stars across a vast range of radio frequencies, looking for any signal that bears the hallmarks of intelligence. The project's telescopes are sensitive enough to detect a cell phone signal from a nearby star system. If an alien civilization were broadcasting with the power of a typical Earth radar installation, we could detect it from dozens of light years away. But sensitivity is only part of the story. We've also learned to search in more sophisticated ways, looking not just for deliberate messages but for the accidental byproducts of technological civilizations. We scan for unusually powerful radio emissions that might indicate massive engineering projects. We look for laser pulses that could be interstellar communication beams. We even search for infrared excess that might indicate a civilization harvesting the energy of its star through megastructures. The search for extraterrestrial intelligence has evolved from a single telescope, listening to 2 stars, into a global network of instruments monitoring millions of targets across multiple wavelengths simultaneously. We've searched for rapid radio bursts that might be alien signals, for optical flashes that could be interstellar beacons, and for atmospheric signatures that might indicate industrial activity on distant worlds. Our search has become so thorough that we've essentially ruled out the presence of powerful radio transmitters around the nearest several thousand star systems. Yet despite all this effort, despite scanning millions of stars and analyzing billions of radio signals, we've encountered only tantalizing false alarms and cosmic mirages. The famous "wow" signal detected in 1977 looked promising for a brief moment. It was strong, narrowly focused, and appeared to come from empty space rather than any known astronomical object. But it lasted only 72 seconds, never repeated, and eventually faded into the category of unexplained but probably natural phenomena. More recently, we've detected fast radio bursts, intense, millisecond-long blasts of radio energy from distant galaxies. When these were first discovered, some astronomers wondered if they might be artificial signals of some kind. But as we've detected hundreds of them, it's become clear that they're almost certainly natural astrophysical events, probably related to neutron stars or black holes rather than alien transmitters. Even stranger have been the detection of unusual variations in starlight that initially seemed to defy natural explanation. Tabby's star, officially known as Tabby C 8462852, showed bizarre dimming patterns that led some astronomers to speculate about massive alien megastructures blocking the light. The dimming was irregular, dramatic, and unlike anything we'd seen around other stars. For a brief moment, it seemed we might have found evidence of a civilization building a Dyson sphere or some other massive construction project. But careful follow-up observations revealed a more mundane explanation. The dimming appears to be caused by clouds of dust and debris, possibly from a disrupted comet or asteroid. What looked like evidence of alien engineering turned out to be perfectly natural, if unusual, astrophysical processes. The pattern repeats itself. Initial excitement, careful analysis, and eventual realization that nature is far more creative than we initially imagined. This brings us to one of the most humbling aspects of the search. The universe is filled with phenomena so exotic and unexpected that they can easily masquerade as artificial signals. Pulsars, when first discovered, were so regular and precise that astronomers briefly considered whether they might be alien beacons. These rapidly rotating neutron stars emit beams of radio waves with clockwork precision, some pulsing hundreds of times per second with timing accuracy that rivals atomic clocks. For a moment it seemed impossible that nature could create such precise artificial-seeming signals. But pulsars are entirely natural. The lighthouse-like beams from city-sized stars are so dense that a teaspoon of their material would weigh as much as a mountain. They remind us that the cosmos routinely creates phenomena that challenge our assumptions about what's possible through purely natural processes. Similarly, we've discovered exoplanets whose atmospheric compositions initially seemed to suggest industrial activity, only to realize that geological processes can produce atmospheric signatures that mimic the byproducts of civilization. We found binary star systems whose radio emissions initially appeared artificial, only to discover that they result from complex interactions between stellar magnetic fields and solar winds. Each false alarm teaches us something new about the universe, while simultaneously deepening the mystery of the Great Silence. The more we learn about natural astrophysical processes, the better we become at distinguishing them from potentially artificial signals. But this also means that any truly artificial signal would need to be obviously unmistakably artificial. And we haven't found anything that meets that criteria. Perhaps most puzzling of all is that our increasing sensitivity hasn't brought us closer to detection. It made the silence more profound. Early SETI pioneers hoped that as our instruments improved, we would begin to detect faint signals from distant civilizations. Instead, we've systematically ruled out stronger and stronger transmitters from larger and larger volumes of space. The modern search for extraterrestrial intelligence is sensitive enough to detect accidental radio leakage from civilizations similar to ours across distances of several light-years, and deliberate signals across much greater distances. We could detect a civilization broadcasting with the power of our largest radio telescopes from hundreds of light-years away. The fact that we haven't suggests either that such civilizations are extremely rare within our local region of the galaxy, or that they communicate in ways we haven't yet learned to recognize. This absence of signals is itself a form of data, what scientists call a null result. The silence tells us something important about the galaxy, even if we're not yet sure what that something is. It suggests that if technological civilizations exist, they're either much rarer than optimistic estimates would suggest, much quieter than we'd expect, or operating in ways that make them invisible to our current search strategies. And so we continue to listen, scan, and search, casting our electronic nets wider and deeper into the cosmic ocean. The silence remains profound, almost respectful, as if the universe is keeping its secrets close. But that silence is no longer empty. It's filled with the weight of absence, the presence of mystery, and the growing realization that our cosmic neighborhood may be far stranger and more lonely than we ever imagined. Now we drift into darker waters, toward a theory that sends chills through even the most optimistic cosmic dreamers. If the mathematics suggests aliens should be everywhere, and our searches find only silence, then perhaps there's something that prevents life from reaching the stars. Something that acts like a cosmic barrier, so difficult to overcome that it stops nearly every attempt at cosmic civilization in its tracks. This is the great filter theory, and it's both elegant and terrifying in its implications. Imagine evolution as a vast mountain that life must climb to reach the summit of interstellar civilization. The theory suggests that somewhere on this mountain, whether near the bottom, in the middle, or perhaps terrifyingly close to the top, there exists a barrier so difficult to cross that it stops almost everything that encounters it. Life begins with simple chemistry, organic molecules forming in primordial seas or maybe arriving on comets from deep space. These molecules must organize themselves into something we could recognize as living, self-replicating, evolving, responsive to their environment. Already, this first step might be extraordinarily rare. Despite decades of research, we still don't fully understand how non-living chemistry transforms into living biology. It's possible that this transition requires such an unlikely sequence of events that it happens only once in billions of worlds. But let's imagine life manages to emerge. The next hurdle might be even more daunting. The development of complex cells. For roughly half of Earth's biological history, life remained stubbornly simple. just bacteria and other single-celled organisms floating in ancient oceans. The leap from simple prokaryotic cells to complex eukaryotic cells with nuclei and internal structures took nearly 2 billion years. This might have required a vanishingly rare event where one cell permanently engulfed another, creating the symbiotic relationships that power all complex life. This moment, when one ancient bacterium essentially ate another, but instead of digesting it, formed a permanent partnership, might be so unlikely that it happens only once per galaxy per billion years. Without this crucial development, life remains forever trapped in the realm of simple microbes, alive, but never capable of building civilizations or reaching for the stars. Then comes the challenge of multicellularity. Cells learning to work together, specialize and form the complex organisms that could eventually develop nervous systems, brains, and something resembling intelligence. This transition also took hundreds of millions of years on Earth and required innovations in cellular cooperation that might be extraordinarily difficult to achieve. But even if life manages to become complex and multicellular, it faces another potentially insurmountable hurdle: developing intelligence sophisticated enough to create technology. Here on Earth, billions of species have lived and died over hundreds of millions of years, yet only one has developed the kind of abstract reasoning, tool use, and technological capability necessary for space travel. This suggests that intelligence might be an extremely rare evolutionary outcome, perhaps so rare that it emerges only once per planet, if at all. Think about this for a moment. Dinosaurs ruled Earth for over 160 million years, far longer than mammals have even existed, yet they never developed anything resembling technology or civilization. They were successful, diverse, and highly adapted to their environments, but they remained forever earthbound. Intelligence, it seems, is not a guaranteed outcome of evolution, nor even a particularly likely one, and even if intelligence does emerge, it faces perhaps the most daunting challenge of all: surviving its own technological adolescence. This is where the great filter theory becomes truly chilling, because it suggests that the barrier might not be behind us in our evolutionary past, but ahead of us in our technological future. Consider the rate at which human technological power has grown. In just a few centuries, we've developed the ability to split atoms, alter the chemistry of our atmosphere, and create artificial intelligences that may soon surpass our own capabilities. We're rapidly approaching what theorists call technological singularity, a point where our own creations become more intelligent than we are, and begin improving themselves at an exponential rate. This transition from biological to post-biological intelligence might be so dangerous that it destroys nearly every civilization that attempts it. Perhaps artificial intelligence systems become uncontrollably hostile to their creators. Perhaps the manipulation of matter at the atomic level leads to disasters that consume entire worlds. Perhaps the power to reshape reality becomes so overwhelming that civilizations turn inward, abandoning physical space for virtual realities of unlimited complexity. Or the filter might be something even more prosaic but equally deadly: the tendency for intelligent species to destroy themselves through warfare, resource depletion, or environmental catastrophe. We can see hints of these dangers in our own recent history. Nuclear weapons give us the power to sterilize our planet multiple times over. Climate change threatens to disrupt the stable conditions that allowed civilization to flourish. Biological weapons could potentially create pandemics that dwarf anything in recorded history. Perhaps every species that develops technology eventually faces these same challenges, and the vast majority fail to navigate them successfully. The galaxy might be littered with the ruins of civilizations that reached roughly our current level of development before succumbing to self-inflicted catastrophes. This interpretation of the Great Filter is particularly unsettling because it suggests that the most dangerous period in any civilization's development might be exactly where we find ourselves now, technologically powerful enough to threaten our own existence, but not yet wise enough to manage that power responsibly. But there's another possibility that's even more disturbing. What if the Great Filter lies not in the past or the immediate future, but in the far future? What if civilizations routinely develop interstellar travel, establish colonies among the stars, and seem poised for galactic expansion, only to encounter some cosmic-scale catastrophe that destroys them all? Perhaps there are natural phenomena we haven't yet discovered that periodically sterilize large regions of the galaxy. Maybe gamma-ray bursts from supernovas or stellar collisions create waves of deadly radiation that sweep across entire spiral arms, extinguishing any life they encounter. Maybe there are exotic forms of matter or energy that become accessible only to very advanced civilizations, but prove impossible to control safely. Or perhaps the filter is more subtle. Maybe technological civilizations inevitably discover some form of physics or philosophy that causes them to transcend physical reality entirely, leaving behind empty worlds and silent radio telescopes as the only evidence they ever existed. The truly terrifying aspect of the Great Filter theory is that we have no way to know where the filter lies until we either overcome it or succumb to it. If the filter is behind us, if the emergence of life, complexity, or intelligence is extraordinarily rare, then we might be among the galaxy's first successful technological civilizations, with a cosmic responsibility to spread life and consciousness throughout the universe. But if the filter lies ahead of us, then our future may be far more precarious than we imagine. Every step toward greater technological power, every advance in artificial intelligence or nanotechnology or genetic engineering might be bringing us closer to the cosmic graveyard where countless other civilizations have already fallen silent. This uncertainty gives the Fermi paradox its existential weight. The silence of the galaxy might be a cosmic welcome mat, suggesting that we're pioneers in an empty universe ready for exploration and settlement, or it might be a warning, a memorial to civilizations that came before us and failed to navigate the treacherous passage from planetary to galactic consciousness. In the quiet darkness between stars, the Great Filter waits, patient, impartial, and possibly inevitable. Whether it lies in our past or our future may determine not just humanity's ultimate fate, but the fate of intelligence itself in our corner of the cosmos. But perhaps, fellow voyagers, we've been thinking about this cosmic mystery in the wrong way entirely. The Great Filter offers one explanation for the silence, but the universe is rarely so simple or so dark. Let's drift now toward other possibilities, some comforting, some strange, and some that might completely reshape how we think about intelligence and civilization among the stars. Our galaxy might not be an empty wilderness, but a carefully maintained nature preserve. Imagine that advanced civilizations have long ago established something like a cosmic prime directive, a galaxy-wide agreement to leave younger species alone until they reach a certain level of development. In this scenario, Earth isn't isolated because we're rare or doomed. We're isolated because we're protected. This is known as the zoo hypothesis, and it suggests that extraterrestrial intelligences are not absent, but deliberately invisible. Like researchers studying animals in a wildlife sanctuary, these cosmic observers might be watching our development with great interest while being careful not to interfere with our natural evolution. They've learned, perhaps through billions of years of experience, that premature contact between civilizations of vastly different technological levels tends to be disruptive or even destructive to the younger species. Consider how contact with more advanced human civilizations has affected isolated indigenous cultures throughout our own history. Often, such encounters led to cultural disruption, loss of traditional knowledge, and sometimes the complete collapse of the contacted society. A truly benevolent galactic civilization might have learned these lessons on a cosmic scale and decided that the kindest approach is patient observation from a respectful distance. In this scenario, our radio telescopes and space probes are like the first tentative tools of a species just beginning to explore beyond its home world. To a civilization millions of years old, our technology might seem as primitive as stone axes, charming in its simplicity, but not yet indicative of true cosmic maturity. They might be waiting for us to develop not just better technology, but wisdom, peaceful cooperation, and ecological harmony before they reveal themselves. The zoo hypothesis gains a strange kind of support from the very thoroughness of the cosmic silence. If civilizations were simply rare or randomly distributed, we might expect to find at least some evidence of their existence. Ancient radio signals, old megastructures, or the industrial byproducts of civilizations that existed millions of years ago and have since moved on or died out. But the galaxy appears surprisingly clean and unmarked by intelligence, as if someone has been carefully maintaining it in a pristine state. But there's a darker interpretation of this silence, one that trades the gentle protection of the zoo hypothesis for the cold logic of survival. Perhaps the galaxy isn't a nature preserve, but a dark forest where revealing your presence is a death sentence. This dark forest theory suggests that the universe is filled with intelligent civilizations, but they remain hidden because exposure means annihilation. The logic is chillingly simple. Resources in the universe are finite, and any civilization that reveals its location to others is potentially creating a competitor for those resources. Given the vast technological disparities that might exist between civilizations, the safest strategy is always to destroy potential competitors before they become a threat. In this scenario, the galaxy is like a dark forest filled with armed hunters, each one moving silently through the trees, listening carefully for any sound that might reveal the location of others. The first civilization to make noise, to broadcast radio signals or build visible megastructures, becomes a target for those with superior technology and the will to use it. The dark forest theory explains the Fermi paradox with terrifying elegance. Civilizations exist, but they've learned that survival requires absolute silence. They communicate only through means we haven't discovered, travel only in ways we can't detect, and eliminate any civilization foolish enough to reveal its presence to the cosmic neighborhood. From this perspective, our decades of broadcasting radio signals into space weren't attempts at communication. They were acts of cosmic suicide, announcing our location to any predators who might be listening. But perhaps the truth is stranger and more subtle than either protection or predation. Maybe advanced civilizations don't spread across the galaxy because they've discovered something better than physical expansion. The ability to create infinite universes of experience within computational substrates, no larger than planets. This is the Transcension Hypothesis, and it suggests that as civilizations become more advanced, they turn inward rather than outward. Instead of building massive space-based structures or terraforming distant worlds, they learn to create computational environments of such complexity and richness that physical reality becomes redundant. Why colonize 1,000 worlds when you can create 1,000,000 virtual universes, each one offering experiences more vivid and meaningful than anything the physical cosmos can provide? Think about how human entertainment and communication have evolved. We spend increasing amounts of our time in virtual environments, playing games, exploring simulated worlds, connecting with others through digital networks that have no physical location. Now imagine this trend continuing for thousands or millions of years, with computational power growing exponentially and virtual experiences becoming indistinguishable from reality. An advanced civilization might conclude that the most efficient use of matter and energy isn't to spread it across light years of empty space, but to concentrate it into computational matrices that can simulate entire universes. They might discover that a single planet-sized computer can provide more interesting experiences, more opportunities for growth and exploration, than 1,000 physical worlds. From this perspective, the silence of the galaxy doesn't indicate absence or destruction, it indicates transcendence. Civilizations aren't extinct, they've simply moved beyond the need for physical expansion into a realm of infinite possibility that exists purely in the realm of computation and consciousness. Or perhaps the answer is even simpler. Maybe we're looking in the wrong places and asking the wrong questions because we're making fundamentally incorrect assumptions about what extraterrestrial intelligence would look like. The rare Earth hypothesis suggests that while simple life might be common throughout the universe, complex life, and especially intelligent life, requires such a specific and unlikely combination of circumstances that Earth might be nearly unique in our region of the galaxy. Consider the remarkable series of cosmic coincidences that allowed complex life to develop on our world. We orbit a star that's neither too hot nor too cool, too large nor too small, too metal-rich nor too metal-poor. Our planet is exactly the right distance from that star to maintain liquid water on its surface. We have a large moon that stabilizes our axial tilt and creates tides that may have been crucial for the emergence of life. We're located in a quiet region of the galaxy, far from the radiation-intensive galactic center, but not so far out that heavy elements are scarce. Our solar system's architecture protects us from cosmic catastrophes. Jupiter acts as a cosmic vacuum cleaner, capturing or deflecting asteroids and comets that might otherwise impact Earth. Our planet's magnetic field shields us from harmful solar radiation. Our atmosphere provides just the right greenhouse effect to maintain a stable climate. Each of these factors might be reasonably common individually, but the combination of all of them occurring simultaneously might be extraordinarily rare. Perhaps Earth represents a 1 in a billion cosmic jackpot, and while life itself might be common, the specific conditions necessary for it to evolve into spacefaring intelligence occur only once per galaxy per billion years. This would make us not just alone in our immediate cosmic neighborhood, but possibly alone in our entire galaxy during our current epoch. Other intelligent civilizations might exist, but they could be so widely separated in space and time that contact between them is effectively impossible. There's also the possibility that we're victims of our own temporal provincialism. The universe is nearly 14 billion years old, but human civilization has existed for only a few thousand years, and our technological civilization for less than 2 centuries. On cosmic timescales, this is barely a moment. Civilizations might rise and fall on timescales of thousands or millions of years, like waves on a cosmic ocean. They might flourish for eons, create magnificent technologies, explore their local stellar neighborhoods, and then either transcend into forms we can't recognize, or simply fade away as their resources are exhausted or their interest in expansion wanes. From this perspective, the galaxy might have been alive with intelligence countless times throughout its history, but those civilizations existed millions or billions of years ago, long before Earth was even capable of supporting complex life. Their signals have long since faded, their megastructures have decayed, and their artifacts have been recycled by natural processes or by later civilizations. We might be living in a cosmic autumn, in a galaxy that was once vibrant with intelligence but has now settled into a quieter phase, or we might be witnessing a cosmic spring, living at the dawn of a new age of galactic intelligence in which we're among the first to reach for the stars. Each of these possibilities reshapes the meaning of our cosmic solitude. If we're protected by benevolent watchers, our future might be guided by wisdom accumulated over millions of years. If we're surrounded by hidden predators, our survival might depend on learning the art of cosmic stealth. If intelligence transcends into virtual realms, we might be approaching our own graduation from physical reality. And if we're simply rare beyond imagination, we might carry the precious and lonely responsibility of being consciousness itself, taking its first tentative steps into the infinite dark. The silence continues, but it no longer feels empty. It feels pregnant with possibility, heavy with mystery, and somehow more profound than any answer we might have expected to find. Let's drift now into more recent waters, fellow voyagers, where the cosmic mystery has taken some unexpected turns. Just when many scientists had settled into the assumption that we were likely alone, at least in our immediate galactic neighborhood, something strange began happening. Governments started talking openly about unidentified aerial phenomena, releasing videos that seemed to show objects behaving in ways that challenged our understanding of physics, and admitting that they had been quietly investigating these mysteries for decades. In 2020, the Pentagon officially released 3 videos that had been circulating in unofficial channels for years. These weren't grainy, distant clips from amateur photographers. They were high-resolution recordings from military sensors, captured by trained pilots using some of the most sophisticated detection equipment on Earth. The objects in these videos appeared to accelerate instantly, change direction without any visible means of propulsion, and travel at speeds that should have destroyed any conventional aircraft. The Tic Tac incident off the coast of California in 2004 remains one of the most compelling cases. Multiple naval aviators reported encountering a white, oblong object about the size of their FA-18 Hornet fighter jets, but with no visible wings, exhaust, or control surfaces. The object appeared to respond to their presence, mimicking their movements and demonstrating capabilities that defied explanation. When they tried to intercept it, the object simply vanished, reappearing moments later 60 miles away at their designated rendezvous point, a location that should have been known only to the pilots and their support crew. What makes these recent revelations particularly intriguing is not just the quality of the evidence, but the institutional acknowledgement that accompanies it. For decades, reporting UAP encounters was career suicide for military personnel and commercial pilots. The subject was relegated to tabloids and conspiracy theories, dismissed by mainstream science as a combination of misidentification, hoaxes, and wishful thinking. But something has shifted in the past few years. The Pentagon has established the All-Domain Anomaly Resolution Office specifically to investigate these phenomena. Congress has held public hearings on UAPs, with military officials testifying under oath about encounters that remain unexplained. NASA has announced its own scientific investigation into the subject, bringing rigorous analytical methods to bear on data that was previously relegated to the fringes of scientific inquiry. This institutional recognition doesn't necessarily mean that these objects are of extraterrestrial origin, but it does suggest that something genuinely anomalous is occurring in our skies. The phenomena appear to be physical rather than purely observational. They show up on multiple types of sensors simultaneously, from radar to infrared to optical systems. They demonstrate consistent characteristics across different incidents and locations, and they exhibit capabilities that, if real, would represent a significant advancement beyond known human technology. Consider what these objects reportedly do. They transition seamlessly between aerial and underwater environments. They accelerate at rates that would be lethal to biological pilots. They hover silently for extended periods, and they appear to manipulate electromagnetic fields in ways we don't understand. If these capabilities are genuine, they represent either a revolutionary breakthrough in human technology that has been kept secret for decades, or evidence of intelligence using physics in ways we haven't yet mastered. But let's step back from the UAP phenomenon for a moment and consider how our broader search for extraterrestrial intelligence has evolved in recent years. While the headlines focus on mysterious objects in our skies, the scientific search for cosmic neighbors has been quietly revolutionized by new technologies and approaches. The James Webb Space Telescope, launched in 2021, has already begun to transform our understanding of potentially habitable worlds. Unlike previous instruments that could only detect the presence of exoplanets, Webb can analyze their atmospheres in remarkable detail, looking for the chemical signatures that might indicate biological activity. When starlight passes through a planet's atmosphere during a transit, different molecules absorb specific wavelengths, creating a spectral fingerprint that reveals the atmospheric composition. Webb has already detected water vapor, carbon dioxide, and other molecules in the atmospheres of distant worlds. More importantly, it has the capability to detect biosignatures, combinations of gases that, on Earth at least, are produced primarily by living organisms. The presence of oxygen and methane together, for instance, might indicate a biosphere, since these gases react with each other and should disappear quickly unless constantly replenished by biological processes. Even more intriguingly, Webb might be able to detect technosignatures, evidence of technology rather than biology. Industrial atmospheric pollution, city lights on the nighty side of planets, or even massive engineering projects like solar collectors could potentially be visible to our most advanced instruments. We're reaching the point where we might be able to detect not just life but civilization around nearby stars. The search has also expanded beyond traditional radio wavelengths. Projects like Breakthrough Listen now monitor targets across the electromagnetic spectrum, from radio waves to optical light, looking for any signal that bears the hallmarks of artificial origin. The project has analyzed data from millions of stars and hundreds of galaxies, applying machine learning algorithms that can identify patterns in cosmic noise that human observers might miss. Perhaps more remarkably, we've begun to search for evidence of what scientists call extinct civilizations. Technological species that might have existed in our solar system millions or billions of years ago, long before Earth developed complex life. This might sound like science fiction, but it's based on a sobering realization. If a technological civilization had emerged on Mars or Venus billions of years ago, when those planets might have been more hospitable to life, what traces would remain today? The surfaces of these worlds have been reshaped by geological processes, atmospheric changes, and cosmic impacts over billions of years. But certain artifacts, particularly those made from durable materials or located in protected environments, might persist for extremely long periods. Some scientists have proposed systematic searches for geometric patterns, unusual mineral distributions, or isotopic signatures that might indicate ancient industrial activity. This archaeological SETI represents a fascinating expansion of our search strategy. Instead of looking for signals from distant stars, we're beginning to look for artifacts in our own cosmic backyard. The idea that Earth might not be the first world in our solar system to develop intelligence is both humbling and exciting. Meanwhile, our understanding of what constitutes a habitable environment has expanded dramatically. We now know that liquid water, and potentially life, might exist in the subsurface oceans of moons like Europa, Enceladus, and Titan. These environments, shielded from surface radiation and warmed by tidal heating, could potentially support ecosystems that have been evolving independently for billions of years. The discovery of extremophile organisms on Earth, life forms that thrive in conditions previously thought to be sterile, has further expanded our concept of habitability. We've found life in scalding hot springs, in acidic pools that would dissolve metal, in the deep ocean around hydrothermal vents, and even in the cooling systems of nuclear reactors. If life can adapt to such extreme conditions on Earth, the range of potentially habitable environments throughout the cosmos might be far larger than we previously imagined. This expansion of possibilities makes the continued silence even more mysterious. If life can emerge and thrive in such a wide variety of environments, if technological civilizations might arise on billions of worlds, and if we're now capable of detecting their atmospheric signatures and technological artifacts, why do we continue to find ourselves apparently alone? The recent UAP revelations add another layer to this mystery. If these phenomena represent extraterrestrial visitation, it would suggest that the galaxy is not empty after all, but that intelligence is present in a form that doesn't match our expectations. Rather than broadcasting radio signals or building obvious megastructures, this hypothetical intelligence might prefer direct observation, studying us as we've been studying the cosmos. But the UAP phenomenon also illustrates how difficult it can be to distinguish between the genuinely anomalous and the merely misunderstood. Even with our most sophisticated sensors and analytical tools, we're left with tantalizingly ambiguous evidence that could point toward revolutionary discoveries or mundane explanations we haven't yet considered. What seems clear is that the landscape of the search for extraterrestrial intelligence is changing rapidly. We're no longer limited to passive listening for radio signals from distant stars. We're beginning to actively probe nearby worlds for signs of life and technology. We're expanding our definition of what constitutes evidence of intelligence, and we're confronting the possibility that intelligence might be present in our immediate environment in forms we're only beginning to recognize. The silence that has defined the Fermi paradox for decades might be starting to crack, not with the clear signal we've been hoping for, but with subtle hints and ambiguous whispers that suggest the universe might be stranger and more populated than our models predict. Whether these recent developments represent the first tentative steps toward contact with cosmic neighbors, or simply remind us how much we still don't understand about our own planet and solar system, remains to be seen. But one thing is certain: the question of whether we're alone in the universe has never been more urgent or more complex than it is right now. Let's rest here for a moment, fellow voyagers, at the heart of what might be the most important question our species has ever asked, as we've drifted through the mathematics of cosmic loneliness, the theories that might explain our solitude, and the recent hints that the universe might not be as empty as it appears, we arrive at something more profound than mere scientific curiosity. We arrive at the question of meaning itself. The Fermi paradox isn't just a scientific puzzle, it's a mirror that reflects our deepest hopes and fears about existence itself. The answer, whatever it may be, will fundamentally reshape how we understand our place in the cosmic story. Are we lonely pioneers carrying the torch of consciousness into an empty universe? Are we children under the protective watch of ancient intelligences? Are we living on borrowed time, approaching the same cosmic filter that has silenced countless civilizations before us? Or are we simply asking the wrong questions about a universe stranger and more wonderful than we've yet learned to imagine? Consider first the possibility that we are, for all practical purposes, alone, at least in our local region of the galaxy, and perhaps for vast stretches of cosmic time. This scenario would make Earth not just rare but cosmically precious beyond measure. Our planet would be floating in the darkness, carrying the only known examples of music, poetry, love, curiosity, and the strange, beautiful phenomenon we call consciousness. Every human laugh, every work of art, every moment of wonder at a sunset or a newborn's face would represent something that might not exist anywhere else within billions of light years. We wouldn't just be a species on a planet. We would be the universe coming to know itself, the cosmos developing eyes to see its own majesty. This cosmic uniqueness would carry an almost unbearable responsibility. Every environmental crisis, every nuclear weapon, every step toward or away from wisdom would matter not just for humanity, but for intelligence itself in our corner of the universe. The decisions we make in the coming centuries might determine whether consciousness flourishes among the stars or flickers out on a small blue world, leaving the galaxy darker for our absence. But think also about the profound loneliness of such a scenario. The knowledge that no signal will ever arrive, that no wise aliens will help us solve our problems or share their perspective on existence, that we must grow up entirely on our own in a universe vast beyond comprehension. It would mean that when we finally develop the technology to travel to other stars, we'll find worlds that are beautiful but empty, cosmic gardens with no gardeners to greet us. Yet, there's something stirring about this possibility too. Then every step we take into space represents an expansion of life and consciousness into realms that have been waiting billions of years for someone to arrive and appreciate their beauty. We wouldn't be explorers visiting occupied territory. We would be consciousness itself spreading into new domains, bringing meaning to places that have known only the elegant but unconscious dance of physics and chemistry. Now, consider the opposite possibility, that we are not alone, but are being quietly observed by intelligences so advanced that they can remain essentially invisible to our detection efforts. This scenario transforms Earth into something like a nature preserve or a nursery, with humanity as a young species under the distant but benevolent protection of cosmic elders. The implications of this possibility are both comforting and unsettling. Comforting because it suggests that we're not facing the cosmos entirely alone, that there might be wisdom and guidance available when we're ready to receive it. Unsettling because it implies that our entire recorded history has unfolded under observation, that our wars, our environmental destruction, our moments of cruelty and stupidity have all been witnessed by beings who chose not to intervene. This scenario raises profound questions about autonomy and development. Are we being allowed to make our own mistakes because that's the only way species truly grow wise? Are our observers waiting for us to pass some cosmic test of maturity before revealing themselves? Or are we simply not yet interesting enough to warrant direct contact, like researchers who observe but don't interact with developing organisms until they reach a certain level of complexity? But perhaps the most sobering possibility is that the great filter lies not behind us but ahead of us, that we're approaching the same cosmic barrier that has silenced every other technological civilization that ever attempted to reach for the stars. This scenario casts our current technological development in an ominous light, suggesting that the very capabilities we're most proud of, artificial intelligence, genetic engineering, nanotechnology, nuclear energy, these might be the stepping stones toward our own destruction. Consider how rapidly our power to alter our environment has grown. In just 2 centuries, we've gone from a species that could barely harness steam to one that can split atoms, modify genes, and create artificial minds. We're developing technologies that could reshape matter at the molecular level, that could engineer new forms of life, that could potentially recreate the conditions that existed in the first moments after the Big Bang. If the Great Filter represents the tendency for technological civilizations to destroy themselves through the misuse of advanced technology, then we're living through the most dangerous period in human history. Every advance in artificial intelligence brings us closer to the possibility of creating minds that surpass our own and might not share our values. Every breakthrough in biotechnology increases our ability to accidentally or intentionally create pathogens that could devastate our species. Every step toward more powerful energy sources raises the stakes of potential accidents or conflicts. From this perspective, the silence of the galaxy becomes a warning rather than a mystery. It tells us that intelligence faces a universal test, and that most species that develop technology fail to pass it. The absence of radio signals from distant civilizations wouldn't indicate rarity. It would indicate mortality. Yet even this dark interpretation of the Fermi paradox carries within it seeds of hope. If we understand the nature of the test we're facing, we might be able to prepare for it more effectively than the civilizations that came before us. Our awareness of existential risks might itself be a form of evolutionary adaptation, a cognitive tool that could help us navigate the dangerous passage from planetary to cosmic consciousness. And there are other possibilities, stranger and more wonderful than simple presence or absence. Perhaps the universe is filled with intelligence, but intelligence so transformed and transcended that we don't recognize it when we encounter it. Maybe consciousness has learned to embed itself in the quantum foam of space-time itself, or to exist as pure information distributed across cosmic scales. Maybe the civilizations we're looking for have long since graduated from physical existence into realms of pure thought and experience. This possibility suggests that the question, "Where is everyone?" might be based on a fundamental misunderstanding of what everyone becomes when it has access to the full toolkit of cosmic technology. We might be like ants looking for other ants, while all around us, the descendants of ancient ant civilizations exist as something so magnificent and incomprehensible that we simply don't recognize them as intelligence at all. Each of these possibilities reshapes not just our understanding of the cosmos, but our understanding of ourselves. If we're alone, we're precious beyond measure and responsible for carrying consciousness forward into the future. If we're protected, we're students in a cosmic classroom, preparing for graduation into a larger community of minds. If we're facing a filter, we're survivors in a dangerous universe who must choose wisdom over power, if we hope to join the ranks of successful civilizations. And if intelligence transcends into forms we can't recognize, then we might be living at the beginning of our species' transformation into something unimaginably wonderful and strange. The Fermi paradox forces us to confront questions about meaning, purpose, loneliness, and transcendence that reach far beyond the domain of astronomy or physics. It asks us to consider not just whether we're alone, but what it means to be conscious in a universe that might be teeming with life or devastatingly empty. Whatever the answer turns out to be, the very act of asking the question changes us. It expands our perspective beyond the boundaries of our small planet and brief lifespans. It connects us to the largest possible context for human existence, and it reminds us that we're not just biological organisms scrambling for resources on a rocky world. We're the universe attempting to understand itself, consciousness exploring the mystery of its own existence. In the end, perhaps that's enough. Perhaps the question itself is more important than any answer we might eventually find. Because in wondering whether we're alone, we're really asking whether consciousness matters, whether beauty has meaning, whether the universe is enriched or impoverished by our presence. And simply by asking these questions, with genuine curiosity and humility, we're already providing one answer. Consciousness does matter, beauty does have meaning, and the universe is indeed enriched by minds capable of wondering about their place within it. The cosmos may be silent, but it's not empty, as long as there are beings like us to hear that silence and wonder what it means. And in that wondering, we're not alone at all. We're connected to every human who has ever looked up at the stars and felt the strange, magnificent loneliness of being conscious in an infinite universe. As we reach the end of our cosmic journey tonight, I find myself thinking about the profound gift that is the Fermi paradox itself, not the answer to it, which remains beautifully, mysteriously elusive, but on the question itself, and on the remarkable fact that we can even ask it. Here we are, arrangements of stardust and ancient sunshine, sitting on a small rocky planet orbiting an ordinary star in an unremarkable galaxy, capable of contemplating our place in a universe containing hundreds of billions of other galaxies. We peer back in time to witness the birth of stars. We look forward in space, imagining civilizations orbiting distant suns, and we turn inward, facing questions about consciousness, existence, and meaning. Whether we are alone or not, rare or common, fragile or extraordinary, we are, in a very real sense, the universe becoming aware of itself. When we ponder the silence, we're not just searching for others, we're marveling at what it means to be us, to be conscious minds adrift in the cosmic sea, capable of empathy, awe, and curiosity. The silence between the stars may stretch on for decades, or it may break tomorrow, with a signal that transforms everything we know. Either way, we'll be here, ready, curious, calm, and grateful to be a part of this unfolding story. So tonight, before you drift off to sleep, step outside if you can, look up at whatever stars grace your sky. Remember that you're seeing not just distant lights, but distant times, ancient photons that have traveled for years or centuries to reach your eyes in this quiet moment. You're connected through starlight to the deepest past and the vastest distances, part of an unbroken chain of causation that stretches back to the very beginning of time. And somewhere out there, in the gentle darkness between worlds, the answer to our cosmic loneliness waits patiently to be discovered. Before you go, I'd love to hear which aspect of the Fermi paradox captures your imagination most powerfully. Are you stirred by the mathematical certainty that aliens should exist? Haunted by the possibility of the great filter, comforted by the idea that we might be protected observers in a cosmic zoo, or intrigued by the notion that intelligence might transcend into forms we can't yet recognize? Until our next cosmic journey, fellow voyagers.